Question 1. Calculate the voltage VO in the circuit below. We can see VO is here, and we have a AC input, and we have some other elements in the circuit. So what we need to do is, because we have inductor and a capacitor and resistor, so it's best to convert everything into impedance. Then it will be relatively easy to calculate Vout. For this question, we assume R is equal to 30 ohm. We can see that the 50 ohm resistor and the 50 microfarad capacitors are connected in parallel, so they can be combined. And since we can simplify the circuit, it will be easier for us to calculate the value we want. Well, to convert everything into the phasor domain, we first need to note down the angular frequency omega. That's 200. Typically, we can find from the voltage source. Now, let's convert the capacitor into impedance. So that's 50 microfarads. We use the formula 1 over j omega c and substitute in the value j times 200 times 50 times 10 to the negative 6, and simplify this, we get negative 100j. For the inductor, we have j omega L, that's j times 200 times 0.1, and this is 20j. We can combine the 50 ohm resistor and the 50 microfarad capacitor. That's 50 ohm parallel with 100 negative 100 j ohm. Multiplication at the top and the plus at the bottom. So that's 50 times negative 100 j over 50 minus 100 j. Is equal to negative 100j over 1 minus 2j, and simplify this, we get 40 minus 20j. Now we can use voltage division to get Vout. Vout is equal to, in phasor form, the voltage source is amplitude 10, angle is 0, so that's 0 degrees. So we have, this is 20j, so 20j over 20j plus 30 plus 40 minus 20j times 10, the angle of 0 degrees. Analysis. j over 70 times 10, the angle of 0 degrees. Vout is equal to 2.857, the angle of 90 degrees. And in rectangular form, you can get 0 plus j 2.857 volts. Question Q2. Calculate the current I in the circuit below. We can see we need to find the current I, and the current I is here. Well, as always, we first need to, the circuit is currently in the time domain. We can record the angular frequency, that's 200, and convert everything into phasor domain. So this is 10, the angle of 0 degrees, have 4 ohm resistor, and the impedance still the 4 ohm. For the 10 millihenry inductor, we have J like L, that is J times 200 times 10 times 10 to the negative 3, and this is 2J. For the capacitor, we have 1 over J omega C is equal to 1 over J times 200 times 5 times 10 to the negative 3. This is negative J. And for 3 ohm resistor, there's still 3 ohm. Well, so now what we can do is that we can simplify the circuit and find the current. The current is for this branch, so we can simplify all of this impedance, combine them together. This 5 millifarads capacitor has an impedance of negative J. So this together is 3 minus J. Okay. C 1 over C equivalent is equal to 1 over 4 ohm plus 10 millihenry inductor. That's 1 over 2J plus these two together, 1 over 3 minus J. And if you simplify this expression, you can get 0.55 minus J 0.4, 1 over this value. And to simplify this further, you can get 1.1892 plus J 0.865. So now the circuit becomes like this. We assume R is equal to 5 ohm. So there's a 5 ohm here, and the impedance, equivalent impedance here is the value here. And the equivalent. So the current I is equal to 10 0 degrees over 5 plus 1.1892 plus J 0.865. And you can get this value as 1.5847 minus J 0.2215. And this is our final answer. Question quiz 3. Calculate the voltage V2 in the circuit below. So for the circuit, as always, we need to first convert everything into the phasor domain and have capacitor, inductor, and resistors into impedance. Well, for this question, it has done for us. We assume R is equal to 8 ohm. So this is 8 ohm. And we need to calculate voltage V2. V2 is a node voltage, so we can perform nodal analysis. Assume all the currents leave that node, so we have V2 minus V1 over negative 2J plus V2 minus 0 over 1J plus 2Ix. Well, our goal is to find V2, but we have two other unknowns. One is V1. Let's see whether we can find V1. V1 is node voltage here. We assume this is ground. All of this is the same node. We assume that's at the ground. So the voltage there is 0. We have V is equal to 0. So V1 is 0 volt. So V1 is simply 0 volt plus 10 angle of 30 degrees. So that's 30 angle of 30 degrees. That's 10 the angle of 30 degrees volt. So now we have V1. Let's see whether we can get Ix. Ix is the current here. So we simply use Ohm's law. We have Ix is equal to V1 minus 0 over 8 ohm. And this is 30 degree over 8 ohm. And we substitute in V1 and add X back to this equation and get 2 is equal to negative 6.1603 minus J 9.3301 volt. Question 4. Given the circuit below, find the average power absorbed by 10 ohm resistor. Well, we need to find the average power absorbed by the 10 ohm resistor. 10 ohm resistor here. To find the average power, we can use the formula P is equal to half I peak R square times the resistance R. Well, we know the resistance, so now what we need to do is to find the peak current Im. To find the current across this branch, let's say that's Im, we first need to solve this circuit. To solve this circuit, let's recall, we don't have any current going through here. Let's say that's Ix is equal to 0. So we can separate this circuit diagram into two parts, the left part and the right part, and solve them separately. Well, let's first solve the right part. We can solve the circuit by using nodal analysis. Let's say the voltage here is V1, and assume all the currents leave this node. We can perform nodal analysis. So this is the same direction, so that's plus 8, 0, plus Ohm's law, V1 over 5J. That's the current across the flowing through the inductor. And then V1, the total impedance for the capacitor and resistor is 10 minus 5J, equal to 0. Well, we can see that we have an I0. That's because we have an dependent current source here. So we need to find out what's the value for I0. To find I0, we can see that I0 is actually the current for this loop. So what we can do is to perform KVL here. That's negative 80 angle of 20 degrees plus 4 I0 plus 0.1 V0 is equal to 0. Well, now we can see that we introduce a new variable, that's V0. V0 is the voltage across the 10 ohm resistor. Let's say, is there any way that we can express V0 by using the variables that we know, what we want to calculate? Well, we can express V0 by using V1, by using voltage diffusion. We have V0 is equal to, that's the voltage across 10 ohm resistor, and the total resistance total impedance is 10 plus negative 5J times the total voltage is V1 minus 0. That's V1. So V0 can be expressed in like this. So now we have 3 equations and 3 unknowns, and we can very easily find the value for V0, V1, and I0. So we can solve for V0 is equal to 80 angle over 20 degrees over 1 plus J. Once we know this voltage value, we can easily find out the current flowing through the 10 ohm resistor Im is equal to V0 over 10 ohm. That is 8 over the square root of 2, the angle of negative 25 degrees. So now let's substitute in this value back to the equation here. So we can get P is equal to 1/2 times, here we only use its real part, that's 8 over square root of 2 square times 10, and you can get 161. Question Q5. Find I0 in the network below. To find I0, we need first to solve this circuit. To solve this circuit, we have KCL plus KVL method or nodal analysis. For convenience, we can choose to use nodal analysis here to find all the node voltages here. So we assume this is V1, this is V2. And then we can write KCL equations at least 2 nodes. Assume all the currents leave the node. For this question, all the values have been converted into the phasor domain, and all the passive elements have been converted into impedance. So we assume this is the ground, that's the reference, with voltage is equal to 0, and this is the same node here, has the same voltage value as the voltage source, that's 100, the angle of 20 degrees. So let's write the KCL equations. 1 minus 100, the angle of 20 degrees, divided by 4J, plus, we have here, we assume R is equal to 2 ohm for this question. So that's V1 minus V2 over 2, plus V1 minus 0 divided by 3 is equal to 0. And similarly for node 2, we can write KCL equation there too. So that's V2 minus V1 over the resistance R is 2 ohm. We have V2 minus 100, the angle over 20 degrees, over 1 ohm, plus here V2 minus 0 divided by negative 2J is equal to 0. And we have 2 equations, 2 unknowns. We can find that V1 is equal to 64.74, the angle of negative 13.08 degrees. V2 is equal to 1.17, the angle of negative 6.35 degrees. So we have found V1 and V2. Then we can find I0 by directly use Ohm's law. That's V1 minus V2 over 2. And the value is 9.25, the angle of negative 162.12 degrees. And in polar form, if we enter this into the calculator and get polar form, that's negative 8.806 minus J 2.841. Question Q6. In the circuit below, calculate the line losses in the transmission line, input voltage, and power factor. So let's first calculate the line losses. To find the power of losses, we first need to, we can use the formula P is equal to I square IRMS square R. So here we know that the resistance value for the power losses is 0.15 ohm. So our task now is to find the current, the root square current for the circuit. To find the current, we have the current is the same for the circuit because everything is connected in series. So we can calculate the current from below here. So I is equal to PL over VL times the power factor. And we know that the power is 40k watts and the voltage is 480. The power factor is 0.9. So we substitute all these values and we can get the R at the root square value for the current is 92.6 amp. So we find the current flowing through the line. Now we can also calculate the power factor angle. We have theta z is equal to negative cosine power negative the inverse cosine of the power factor is 0.9, and we can get negative 25.84 degrees. So here we found the amplitude. Here we get the angle. So IL, the complete LL is 92.6, the angle of negative 25.84 degree RMS. So now we need to calculate the line loss, the power of line loss. That is P is equal to, we substitute in the value for the current, we directly substitute in the amplitude, that's 92.6 square, and R is here 0.15, and you can get the line loss is 1.286 kilowatt. Well, now we need to calculate the input voltage. The input voltage, Vs, provides voltage to both the lines and the load. So we have Vs is equal to, by using Ohm's law, the total impedance is 0.15 plus J 0.3 times the current, that's 92.6, the angle of negative 25 0.84 degrees. And plus the voltage for load here, that's 480 volt. And to simplify this expression, you can get Vs is equal to 504 volt, 0.97, the angle of 2.15 degree volt. This is also the room square value. To find the power factor, we have power factor is equal to the cosine of power factor angle, that's the phase for the voltage minus the phase for the current, theta V minus theta I. And this is cosine 2.15 minus negative 25.84, and you can get 0.883 is the power factor. Question Q7. What power factor at the load side should be in order to maintain the transmission line losses at 1.5 kilowatts? So this question asks us to find the power factor for the load so that the energy, the power losses by the wire can be controlled at 1.5 kilowatts. Well, for this type of question, the first step is always to find the IL, the current flowing through the wires, or this whole circuit, this whole loop. We want to have the power loss to be 1.5 kilowatts. That is IL square times 0.15. And this is the room square value, so we don't have 1/2. And this is equal to 1.5 kilowatt. Thus, we can easily find the IL is equal to, take the square root of, this is 1.5 thousand, so it's 1/500 over 0.15, that's 100 m room square value. Well, to find the power factor, we know that LL can be calculated as PL over VL times PF. So here, you know that the power here is 40 kilowatts. VL is 480 room square value. And we know the current. So it's very easy to find that the PF is equal to 0.833. Thank you guys. This is our last assignment. Thank you so much for staying around for this whole term. And wish you all the best for the future and good luck on your final exam.